Okay, so this is recording for Tuesday, March 12th, and we are working on our notes for 4-3. We're writing homework 3 today. It is due on Thursday of this week. We're talking about trigonometric functions for any angle. We will have an alternate way of looking at this as we go through the chapter and progress, but right now, this is it. And I usually memorize these sine, cosine, tangent, and then the reciprocals of those, cotangent, secant, and cosecant. If you were here on Friday, we talked about the fact that if you consider the right triangle to be in that first quadrant, then it's easiest to understand what's happening because the x and the y values in the first quadrant are both going to be positive. So that means in this little right triangle, this is going to be our angle theta. Theta is always made with the positive x-axis and then rotates counterclockwise if it is a positive angle. We'll be talking today about variations of that, so you want to be paying close attention as we go. So if this angle is theta, we know that if this point is x and y, that means x is that distance, y is this distance, and we said last Friday, I'll pretend to draw a circle here. If I have a circle here, this side of that would be the radius, and so to get that radius, we can use the Pythagorean theorem. I'm going to get rid of that circle because I don't truly want it up there, and this is the radius of the circle. That's why we call it r. And the radius or that hypotenuse of that right triangle, r, is the square root of x squared plus y squared. If you ever get yourself in a situation where you can't remember what these are, like which one is y over r or x over r or whatever the case may be, and I'll give you kind of a little way that I kind of help myself remember, you can always draw this picture. And I'm going to say this, even if it's in a different quadrant, so look, I'm going to draw it in a different quadrant, and I'm going to know that theta really goes all the way from there to there, but I can use something I'll call theta prime, and that's always an angle made with the positive or negative x-axis. And remember the angle of elevation, angle of depression, always horizontal up or horizontal down. This is going to be the same thing. That angle that you have to think about making that little triangle, it's always going to be horizontal down or horizontal up. Here, horizontal up or horizontal down. And we'll cover that later. But if you think about that, then your point xy is here. Notice x is negative, right? And y is negative. So not really, so we're trying to put this on a right triangle, but it's really not, because now that's like a negative. I'll say this is like -3, -4, because then it'll be a 3, 4, 5. So that means the x, -3, -4. So that means the x is -3, the y side is -4. That radius, do you agree it'll be positive no matter what, right? Because when I square the negatives or positives, they'll always be positive, add them together, and then square root it. And so I can set up this little triangle, and if I use this small angle here, I can get these without having to memorize them. Now, having said that, if you memorize them, you'll be more efficient. But if you ever get yourself in a situation where you're like a little bit unsure and you're getting frustrated, when in doubt, draw it out in trigonometry. So that's going to be a guide that I'm going to tell you as we go. The other thing I'll say is And in a little bit, we'll talk about a unit circle, and a unit circle means that radius is 1. Do you agree? Unit circle is 1. And so there the radius will always be 1. The circle will be centered right at that origin. And then think about if the radius is 1, wow, these are going to be easy, right? Because if the radius is 1, that's going to be y. That's going to be x, correct? And this will still be a fraction of y over x. But notice that sine is y, cosine is x. So in my head, the way that I remember that is I remember that, you know, my ordered pair x, y are alphabetical, right? X then y. And then really cosine goes with x. Cosine goes with the x part, and sine goes with the y part, and alphabetically, cosine comes before sine, alphabetically. Now, I still generally just do it this way. We're also going to learn later on, not right this minute, how to decide whether an answer is positive or negative. But right now, if it will decide for itself. Does that make sense? Because if x or y is negative, this will be negative, right? This will be negative. If x and y are both negative, that'll go back to positive. Do you agree? But r is always positive, so it's not something to be thinking about as we go. So the nice thing is, I told you draw this triangle, and you can draw it in any quadrant. The nice thing is, actually, you know, we can still use that angle theta that was here, but if you kind of think about the right triangle as using that angle, it'll work out. So let theta be an angle in standard position, positive x-axis, counterclockwise. The point PXY is any point on the coordinate axis, and it's on the terminal side of the angle. R is the distance from the origin, and we just said R is like the radius. And then here are our trig functions. Sine theta is y over r, and it's still opposite over hypotenuse. Cosine, adjacent over hypotenuse. So looking at it in that first quadrant can kind of be a little bit of a guide to you. Now, if you couldn't get the 6 trig functions on that last quiz, you know, after this lesson, we'll have just gone over them yet again. And it is an expectation in this course that we know all 6 of those trig functions. And there is a lot to remember, but I'm not good at memorizing things. But I am good at seeing patterns, and there are so many patterns in trigonometry. You don't have to know that much if you can follow the patterns as you go. So this is our first problem, and it's going to be an easy problem because x and y are 3 and 4, so r is 5. Do you agree with that? But if r isn't, you know, if it's not a 3, 4, 5 triangle or some Pythagorean triple, we do have to get things in simple radical form and find radicals. So we have to do a couple things here. Give all the trig functions, and we have to be able to graph this as well. So let, for number 1, this negative 4, 3 is a point on the terminal side of theta in a standard position. Find the exact values of the 6 trig functions of theta. And I'm going to just graph it because I know you're going to have to. So negative 4, positive 3, I'll go up less than I went out. I guess I'll just say it that way. Negative 4, 3. I'll color code this a little bit. There's my initial side. This is my terminal side. Oh, I kind of missed my point, but I'll just, there we go, make it work out. And so our angle theta is right here. We don't have to know what theta is. And in a way, we you know, don't even care that much what it is. And then if we've forgotten in our minds, we can draw a little right triangle here. And this is negative 4. And this is positive 3. Our angle is right there. R is the first thing we're going to find. Square root of negative 4 squared plus 3 squared. Square root of 16 plus 9. Square root of 25. So R is 5. And we knew that already. But if it's not a number like that, we'll have to be careful. So here's xy. If we know the trig functions from that last page, we can just write them down. If we don't, we can use this picture. Do you agree? So I know that the sine of theta, and by the way, I will just comment on this from the quiz, it has to be the sine of theta. And it's not the sine, well, it's the sine of theta equals y over r. So the sine of theta is 3 over 5. It's not the sine of 3/5, because actually that's something different. That's really saying to me that the angle is 3/5, which is a fraction, 0.6. It's probably in radians if there's no label there. And so that's what I'm going to do. And so the sine of the angle is the y over r. The cosine of theta is x over r. So the cosine of theta is -4 over 5. The tangent of theta, and remember, at this point, if I can get those two, I can get all 6, because the tangent is just sine over cosine. Well, the 5's will cancel. It'll be 3 over -4. But if I'm using my rule, it's y over x. And I can use my rule the same way. So the tangent of theta is 3 over -4, so -3/4. Usually we'll put the negative like out in front. I put it on the top for that first one. And then I'm just going to write mine in reverse order. So tangent theta is -3/4. Cotangent theta is -4/3. Now I'm just going to flip all these. Secant theta is -5/4. Cosecant theta is 5/3. And now maybe it'll sink in a little bit more. I've said this before, but these are, there's one co in every pair of inverse or reciprocal functions. Sine, cosecant. Cosine, secant. Tangent, cotangent, okay? There's one co in every reciprocal function. So one will be a co, one will not. And hopefully we can do that if we need to. Now, I'm going to show you these slides, but I'm also going to tell you kind of the way that I do things a little bit, because in my opinion, the book authors give you an awful lot of information, and I just can't memorize or remember it all. Now, those are functions that have that are out in a quadrant someplace. These are called quadrantal angles, and so for these, and I'm just going to draw 1, 2, 3, 4, and this is maybe what you want to write on your paper. If the terminal side is on an axis, so that means initial side is always on the positive x-axis, then the terminal side might be on the positive x-axis as well, or it might be on the positive y-axis, the negative x-axis, or the negative y-axis. So this is 0 degrees. This is 90 degrees, and or pi radians. That's 0 or 0 in radians, or, and, oh, pi over 2, my bad. 90 or pi over 2. This is, and so we'll draw these arrows in here. This is 180 degrees, or pi, there's pi. And this one is 270 degrees, or 3 pi over 2, 1.5 pi. Now, to make quadrant angles easy, we're going to pick a point on that axis, and then we're going to follow that same rule before. If my angle is 0 degrees, can I make a triangle there? I cannot. So, you know, if I wanted to, I could kind of make a little triangle and say this is some length and that's 0, you know what I mean? And it would work that way. But I want to just kind of be able to do this for anything. keep this in mind. When when I'm deciding R is going to can be any length. So the most convenient R value to pick is let R equal 1. So when I do this and when I ask you to do it, I generally pick these points. And instead of drawing 4 axes when I draw it later on, I draw 1 axis and I put those 4 points on it. But since we're kind of going over it for the first time, I'm going to put a point there and I'm going to give it convenient coordinates. 1, 0. Do you agree? Oops. And I was just going to write 0, 1. 1, 0. I'm going to pick a point there and give it convenient coordinates. 0, 1. I'm going to pick a point on here. I'm going to give it convenient coordinates. The most convenient number I can think of is -1, 0. So -1, 0. And this one, I'm going to pick as 0, -1. And then in the future, when I do these, because really, you know, that's going to take up a lot of space. In the future, I can say any of these quadrant angles, they're going to be one of these as we look at it. And it's going to be x, y. The nice thing about this is for every one of these, do you agree? I can't see that one. Do you agree that R is 1 also, correct? Positive 1. Yes or no? Yes, R is +1. So that's another thing. It just makes it super convenient. So like, you know, if I picked 5 there, R would be 5. So 5 divided by 5 would be 1. 1 divided by 1 is 1. So it just makes it a little easier as we go. And so again, later on, I'll just draw that one way. So if I can pick any point on the quadrant, on the axis, and get this quadrant angle, then I can find those trig things. And if I need to remember, I can always say this, that in my head, I have this picture, right? Theta, this is x, this is y, that's r. Do you agree? So let's pick an angle like pi or 180 degrees. And I just said that this value is -1, 0. And so when you look at this picture, because that's what the picture should be in your mind, you know the sine of theta is y over r. Oops, y over r. Here, this is x, this is y. R is the square root of -1 squared plus 0 squared. So r is 1. So then for this, sine theta is y over r, 0 over 1, which is 0. Do you envision that some are going to be undefined sometimes when we're doing this? And then when I have this picture in my head, cosine theta is x over r. So x over r, cosine theta is -1 over 1, which is -1, right? I'm not even going to write it as a fraction. Is that okay? Okay. And then tangent theta, well, tangent theta is y over x. Y over x, 0 over -1, that's 0. So now, I'm just going to flip them all upside down. When I flip that one upside down, I have an issue, don't I? What is it? It's -1 over 0, and that is undefined. I can't have a 0 in the denominator of my fraction. Now, I don't know if you remember that table that we made that other day, and we haven't really talked about it since, but we will talk about it in this section and going forward. But in that table, we have 0 degrees and we have 90 degrees. And so we have on that table, if you can generate that table, the sine, cosine, and tangent of 0 and 90. But that's one of the reasons I picked 180 as the angle. So what is secant theta? What happens when you flip that upside down? Oh, -1 is like -1 over 1. So it's 1 over -1 or whatever. So it's the same thing flipped upside down. Cosecant theta, what's that? Undefined. Oops, undefined. So generally, these on the quadrant angles, all the sine, cosines, and tangents are going to be things like 0, +1, in this case, -1s, but you know, if we were using the one that's over here as a +1, that one has a +1, 0, -1, +1, or undefined, right? And they're always going to be that way on the quadrant. And that's what's going to happen. And if we can make this picture in our head, even though, can I make that triangle here? No, right? I cannot make that triangle in this situation. But if I have that triangle in my head, I can answer any of these. So, oh, here's the cosine of pi. Well, there we go. So 2a. And by the way, same with the last quiz and the next quiz and the quiz after that and the test. We are huge in trigonometry on exact answers whenever we can get them. And so, you know, if it's the, you know, the last one was the square root of 25, which is 5. But if it's the square root of some number, we're going to use that, and that will be our exact answer in simple radical form. So this is the cosine of pi. They're only asking us for one of those. So it's a quadrant angle. I'm going to put my little dot there. I'm going to label it as -1, 0. This is x and y. And r is 1. I know that because that's what I get. And the cosine of theta is, and you know, if you need to, think about your little picture. Here's theta, there's x, there's y, here's r. Cosine is x over r, and so in this case, x over r is x over r, and so in this case, x is -1, r is -1, -1 over 1, which is -1. So that's the exact value. And notice it's saying, you know, or undefined, because we know our answers on the quadrant are 1, -1, 0, undefined. If you don't know, guess one of those, I would say. Now, 450 degrees, is that 0, 90, 180, or 270, or 360? No. So we have to spin around and think about where that is. 2b, tangent 450 degrees. So for this one, not always great at arithmetic, but it's going to spin one time around, which is 360. How much is left after that? 90 degrees. So here's my angle. It means I start my positive x-axis and I go around 360. Oh, excuse me. And then over here to 90, and there's my angle. By the way, on the last quiz, I'm talking about that now too, because you can improve yourself if you want to retake that. That spinning always starts at the positive x-axis. People were starting that spinning like, you know, here and going around like that, or I don't know, just a lot of different things. Always positive x-axis, that is the initial side of those. So I know I'm ending right there. I'm going to call that point 0, 1, and that's x and y. What is r? What is r? 1, r is 1, and I need the tangent of theta, and so if I need to, in my head, I'm putting this little picture there. So I personally have drawn this picture at least 4 times today, maybe even more than that. I feel like I did more than that. And so is it in my head real well? Absolutely. Are you writing it down? Are you writing it down more than once? Because that's how your brain is going to pick up that pattern and know what it is if you don't already know what it is. Tangent, opposite over adjacent, so y over x. I don't memorize that little chart that we wrote at the beginning of the hour. I kind of, well, maybe I did memorize it, but really in my head, I have this picture that I don't have to physically draw all the time. And so tangent is y over x, tangent of 450 degrees. What's y over x? Undefined. 1 over 0, so it's undefined. defined. So this little thing is my kind of general way of doing it. This is my picture for where I am right now. And actually, I can use this kind of picture for any coordinate point. 5 comma negative 3 and 7 comma 15, anything that I need to do. But they do give you a lot of quadrantal angles, because those tend to be a little trickier. Now, this one is in radians. Now, I'm going to tell you this. Since you're probably more familiar with degrees than radians, would that be a fair thing to say? In general, you're more comfortable with degrees than radians. At this point in your life, if when you look at that, that's hard to do, go ahead and convert it into degrees and then just do it that way. But a word of caution, as you go on in math, if you have to take more math classes after this one, then you need to kind of really embrace radians at some point in your life. But right now, you can get the same answer. By the way, how do I convert that into degrees? I'm not going to, but just, so I want the pi's generally to cancel out. So 180 over pi, oops, and then I'll get that in degrees. If you need to, go ahead and do that, but we'll try not to when we do it together as we go. So for this one, I have to figure out where 7 pi over 2 is. And think about this. And this you want to know. This is 0. 90 degrees is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. So these go by a half, right? So I'm going to count them. I don't know if I can spin and count at the same time, but I'll point and count, and then I'll write in my spinning. So look, 0, a half, 1, 1 and a half. Oh, a 0, 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves. Did you notice how I restarted counting? Why did I do that? Because it's in halves, so I might as well just count by halves. 0, 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves. It's fractions, but I can make it pretty easy for myself. So there's my initial side. So 0, 1, 2, 3, 4, 5, 6, 7. I end up right here. I'm going to call that point 0, negative 1. There's x and y. What's r? 1. And, the Janet Jones method is not always the book author method. Janet Jones would figure out the tangent and then flip it. How many of you would maybe do it that way? I don't know. I just find the main 3, and if I have to, I flip it. And so my alternate work is I'm going to remind myself the tangent of theta, and then here's my little picture. I've got x, y, and r, and theta is right there. Tangent theta is y over x. So what's cotangent theta? Cotangent, oh, that not cosine, just kidding. Cotangent theta is x over y. So, I can do it now. I can do it after it's numbers. But I do want to be careful, because if one is undefined, the other one is defined, right? So be careful there. X over y, 0 over negative 1, what is that? 0 over negative 1. And so that is equals 0, cotangent 7 pi over 2. And I do count by whatever my denominator is of fractions, just like I did. Half, 1 half, 2 halves, 3 halves, 4 halves. It helps me as I go. So far, so good. Are you getting this idea? Are you getting that drawing of a right triangle, the x and the y, the r, and whatever happens, happens? Now, to me, that's intimidating. I think it's hard to follow. I'm going to go over it, but then I'm going to tell you maybe a different thing to write down or know as you go. Yeah, so that's a little intimidating. But here's what I'm going to tell you you need to know. And I'm going to draw my pictures over here, which, trust me, I think mine are easier, because I'm not going to do all of this, but I can look at it, woohoo, and feel happy about it. So I'm going to actually draw 4 of these. I don't know if I can fit them all on this page. So I will go down here for my last one. Okay, so do you agree the initial side is always in the same place? Positive? Yes or yes? Okay. Positive x-axis. So initial side, initial side, initial side, initial side. We talked about the quadrantal angles, so we're not talking about them anymore, right? Because we can handle that. Where can the terminal side be? Tell me quadrant. Look, 1, 2, 3, 4. It can be in quadrant 1. It can be in quadrant 2. It can be in quadrant 3, or it can be in quadrant 4. Do you agree? Okay, so that's what I'm going to do. And which one didn't they draw? Quadrant 1, because, why didn't they draw that? Because quadrant 1 is something we're most familiar with. And when you draw that little triangle we've been talking about, it's going to be in quadrant 1, right? So it's going to be easy to kind of figure out. So this is our angle theta. Oh, they're going to call it, here it is. They're going to call this theta and theta prime. So sometimes my theta and my theta prime, because I'm writing on the smartboard and it's hard to see that prime. I generally call this the reference angle, which is what it is. The reference angle. I sometimes don't even use the theta. I just say my ref angle, so I'm telling you that also. So this is our angle theta. It goes from here to here, from there to there, from here all the way around to there, and from there all the way around to there. To find the reference angle, remember angle of elevation and angle of depression, always from where? How does an angle of elevation or angle of depression start? What's the initial side? Which is horizontal, right? Horizontal up, horizontal down. Oh, look, I'm like an alligator. I'm sorry. Right? So horizontal up, horizontal down. So that's what you have to remember. Reference angle is always horizontal up or horizontal down. And so the initial side of the reference angle is always from the positive or negative x-axis. So look at this, and I'm color coding it. Oh, I didn't say that these are all theta, is the blue angle. Excuse me. The red angle is going to be the reference angle. Look. If it's in the first quadrant, the reference angle and the actual angle are exactly the same. Except if it spins and ends up there, then the reference angle is just that short angle between 0 and 90, or 0 and pi over 2. So this one, just give me a head nod. Do you think you know where the reference angle is? Right here. It's going to be this horizontal up to the terminal side, right there. And here's the deal. The reference angle is always between 0 and 90, or 0 and 2 pi, and pi over 2, excuse me, not 2 pi. So look at this one, a little tricky. Give me a head nod. Do you think you know where the reference angle is? Okay, I have to go from the positive or negative x-axis. Which one do you think I should use? Negative x-axis, and then I just go the quickest way to the terminal side. Right there. Do you agree? See it? So now, do you know where this one is? Positive x-axis and terminal side. There's the reference angle. Do you agree that all of those are going to be between 0 and 90, or 0 and pi over 2? Right? Which is 90 in degrees. That's the reference angle. Now, think about labeling this axis. Well, can we ignore that one a minute, because it just is what it is. So if I label this axis in degrees, 0, 90, 180. 270, 360. So if I needed to get this and I had that angle, I'm going to say it's 100 degrees, right? Because it's more than 90, less than 180. If it's 100 degrees, what's the reference angle? 80, right? Do you agree? Okay, so that's what we do is we take 180 and we subtract. For this reference angle, do we still use 180? Because that's where this is coming out. And do we still subtract? I think we do. I think we do, because look, the blue angle, I'm going to make something up for the blue angle. I better go kind of easy for myself. 200. Do you agree? Because it's between 180 and 270. If that's 200, what's that? The reference angle. 20, right? 200. If from there to there is 200, from there to there, because this is 180 to 200, that's 20. Do you agree? So here's the nice thing. If the terminal side is in quadrant 3 or 4, you're just going to take either 180 minus the angle or 180 minus the angle or the angle minus 180, whichever way you have to go, right? Now, what are we going to do over here? This is like a 300-degree angle. What's that going to be? 60, right. So you're going to think about going all the way around here to 360 and then subtracting off, we'll say that was 300 or whatever, and then the reference angle is going to be 60. It's always to the positive or negative x-axis, and that answer should always be between 0 and 90, or, you know, the other thing is if it's in radians, 180 is pi, so pi minus the angle minus pi, 2 pi minus the angle, and that's how we get the reference angle, okay? Now, they go through this whole entire thing, and then they kind of help you figure out where things are. I'm only using this right now to get the reference angle. The trig things, we're going to do it in a little different way in a minute here. Do you agree that we've had the positive and negative x's and y's, correct? And r is always positive. Do you remember that a minute ago? Okay, so here's the nifty thing about this. Yes, nifty. All students take calculus. There's a mnemonic device. Remember SOHCAHTOA, right? SOHCAHTOA is a mnemonic device. Okay, this one, and you know, is all students take calculus. I'm just going to tell you, when I was in high school, that's what Mr. Grenzer said, and that was my high school math teacher. All students take calculus, and gosh, I did. Okay, so, but it doesn't matter. It's a mnemonic device that helps you remember okay, and here's when I have to spell words. It helps you remember the sign of a trig function. The word's S-I-G-N. So that means positive or negative. Look, what are the trig functions? The first three. Okay, what do you think that stands for? Exactly. All sine, tangent, cosine. Now, here's what does it mean? It talks about the positive or negativeness of the answer. So, do you agree that x and y are both positive in that quadrant, correct? And so all trig functions are positive. Do you agree? All trig functions are positive. Here, sine is positive. What do you think is true about cosine and tangent? They are negative, and their reciprocals follow. Do you know what I mean when I say their reciprocals follow? Yes or no? Who's positive here? Tangent. And think about it. X is negative, y is negative. What's tangent? Y over x. A negative divided by a negative is a positive, but sine and cosine are both going to be negative. So that is going to help you decide whether an answer is positive or negative. Now, this just tells you how to find those. Did we go over this already? Look at it. Megan, if you want to get the handouts, they're right there by the gray tray. Okay, awesome. So here we are. Oh, did you remember having to sketch in the last quiz? Yeah. So if you practice that, you know how to do it. If you didn't practice that, you still have a chance to learn. Negative 150, what direction do I go? Clockwise, yes, or down. Either way works for me. Positive x-axis, and it's in degrees. Look, 90, that's 180, right? So it's going to be someplace in there. Do you agree? I don't, oh, as long as it's in the right quadrant, I'm not gonna, it's not an art project, so negative 150 degrees. And then its reference angle. Just give me a head nod right now. Do you know where you would draw in the reference angle? Yes or no? Okay, positive or negative x-axis? Negative x-axis down to this side. Now, even though that's negative 150, can you figure out what that reference angle is? It's 30. Reference, angle, and in my head, I'm just taking 180 minus 150, just like, I would. The reference angle is 30 degrees. And you're going to find these reference angles are always between 0 and 90. This one is in radians, a little harder, but not above us. And so here it is. Now, I'm going to, because radians are a little harder and it's positive, so I'm going to go this way. I'm going to start labeling my axis. But what's my denominator? 4. So instead of writing 2's as my denominator, I'm going to write them as 4's. So this is a half, which would be 2 2 pi over 4. I'm sorry. This is pi, which is 4 pi over 4, right? This is 3 pi over 2, so it's 6 pi over 4. And then this is 8 pi over 4. I'm going to tell you, if fractions are hard for you, go ahead and label axes like this using that denominator and just count, because now it's easy to count. Where's the initial side? Positive x-axis. Where's the terminal side? Quadrant 1, 2, 3, 4. Oh, don't Spanish me out of my job. Okay, 3 pi over 4. Reference angle. Do you know what it is? Pi over 4. Because look, 3 pi over 4, 4 pi over 4. It's right there. The reference angle is, the reference angle is pi over 4. Pi over 4. Not too bad, though, really, is it? Now, here's how to find the reference angle. You have to know how to find the reference angle. Oh, no. Wait a minute. I'm going to say this. Shh. You just have to know that, and we've talked about it a bunch already. Now, wait a minute. Sit down. Yeah. Because I'm not to the second half of the lesson, and so I need a lot of times. Ask me about all students take calculus. Did we talk about that already? Yes. Ask me about generating a better table. You can do it already. You can generate the better table. You're going to do it right now. Write this on a piece of paper, and I'm going to tell you eventually you have to memorize this. So if you're going to write it in your notebook, designate a spot that you're going to write it so that you can sit and look at it when you need to study it. Are you ready? Because you're writing it before you leave today. The table, you've written it before, a quadrantal angle, and all students take calculus for sure we'll put on there. So I'm just going to remind you, and here it is. So this is going to be radians, degrees, sine, cosine, tangent, theta, theta, theta. And go to the degree line. It's 0, 30, 45, 60, and 90. And it's 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1. 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Tangent, sine over cosine. 0, 1 over the square root of 3, which is the square root of 3 over 3. 1 square root of 3, undefined. Radians, 0 is 0. 30, Think about the relationship between 180 and 30. 180 divided by 30 is 6, right? So this is pi over 6. 45 is pi over 4. 60 is pi over 3. And this is pi over 2. Other things you need to know is you need to know any quadrantal angle at any moment. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And you need to know that all students take calculus. If you know those things, you're going to be able to find a lot. And maybe you don't know them this minute, but that is a page you want to study. We're going to add just a little bit to that, but not today. When you have that done, stack those chairs.